you might actually see the live broadcast before I do. Sometimes this software works really funny. And if you have seen it, just let me know and then I'll introduce you because I haven't seen it yet.
It tells me that it's been live for 20 seconds for what that.
You know what? I don't doubt that at all. And on my end, it's still saying we aren't, but I believe you, Bryan. So I'm going to say, hello, everybody. I'm Brent Leary. And this is my first, I think this is the first live stream of the week for me, which is a little later in the week than usual, but it's actually a really great way to start because with me right now is Bryan Catanzaro. He's the Vice President of Applied Deep Learning Research for NVIDIA. Bryan, thank you for joining me, man. It's really good.
Of course, glad to be here.
So I know NVIDIA for I don't do a lot of gaming, but I do a lot of video editing stuff. So I'm used to you guys because you guys have the great graphics accelerator cards. And if you want to do anything with graphics and stuff that's like gaming or deep level video editing, you need great graphic adapters and GPUs. And that's what I know NVIDIA for. But over the last couple of years, NVIDIA has started hitting my radar beyond that into things that are I've been looking at from a CRM perspective, which is AI and deep learning and conversational interface and all that kind of stuff. So this is really cool to talk to you about that. Before we jump in and start digging in, maybe you can give us a little bit of your personal background.
Yeah, well, I got my PhD from Berkeley. And I graduated 10 years ago. And at the time, I was looking at how can parallel computing influence machine learning, and how can we use parallel computing to make machine learning much more powerful and much more useful. And I decided to do that work after I graduated at NVIDIA. So I joined NVIDIA Research in 2011 and worked on a bunch of things, but especially worked on libraries for deep learning on the GPU. And back then, this was still kind of a countercultural thing to do, I suppose. There weren't a lot of people that were using GPUs for artificial intelligence, and it was kind of a nascent market. But the research I thought was pretty promising, and so it was something I believed in, and that ended up working out really well. So my research led to the creation of cuDNN, which was NVIDIA's first library to help people use the GPU for artificial intelligence. Mm. And that was really exciting to be involved with. I decided that I wanted to be more involved with the creation of applications using deep learning, not just working on the sort of platform technologies that enable people to use parallel computing to do deep learning, but I wanted to work on deep learning applications themselves. And so in 2014, I decided to go work at Baidu, which is a Chinese search company, because they were building a new AI research lab here in California. And that gave me a chance to work on applications a little bit more directly. And I did that for about 3 years. And then I decided that it was time for me to move on to my next project, and NVIDIA asked me to come back and build an applied research lab that focuses on using AI to help NVIDIA's products become better and help NVIDIA be more efficient as a company. So I've been doing that now for 5 years, and my team is about 40 full-time researchers that are doing things in graphics, conversational AI, and systems design. Basically figuring out new ways of using AI to make NVIDIA better. And so that's what I do full time these days. And I think, we've had a lot of impact. There's a lot of excitement about how to use AI. Also a lot of questions because, the technology is still being developed. And so it is fundamentally a research activity in a lot of ways to figure out how to use deep learning for a new problem. And that's kind of what my team specializes in doing. Some of our recent projects that I'm really proud of include Dlss, which makes a small GPU look like a big GPU when you're playing a video game, because it's a more intelligent rendering algorithm that is less brute force, because we're able to use AI. And so that actually magnifies the capabilities of our GPUs and makes them much more efficient and therefore more useful. And then also our Megatron project, which is about how to train the world's most advanced and most exciting language models at scale on large clusters of NVIDIA GPUs at the absolute speed of light. Language modeling these days is really revolutionizing a lot of the industry, and it's very exciting, the capabilities of these models. So we've been involved in showing people how to do that properly, and what kinds of algorithms and systems support is necessary for that. And we've also done a lot in speech synthesis and conversational AI. Making speech synthesis more realistic. Recently, some of our speech synthesis algorithms have been used to create the I Am AI videos from NVIDIA that are being narrated by a computer narrator. And if you've ever listened to those, you'll find that the narration has a lot more humanity in it than you might expect from a computer. And so that's been part of our research as well.
In fact, Bryan, since you brought it up, let me play this, and maybe we could come back to that for a second. Let me play you this little clip.
I am a visionary, bringing history to life, and adding motion to memories. I am painting with the sound of my voice.
A peaceful lake surrounded by trees.
And letting art speak for itself.
Did you know that white rhinos and black rhinos are both gray?
I am changing the way we see the past.
I almost didn't want to stop that, because that was really some good stuff. And I was talking with one of your folks, Anna, earlier. It's not only the power of what that was going on, but it was also the dramatic music. There was a lot of stuff going on in that video. You had just explained that voice we heard, it wasn't an actual human being, was it?
That's right. That was synthesized with some of our most recent voice technology.
It sounded like a real human being to me. We're used to hearing like the Alexa in the series, and before that it was like, we don't even want to talk about the voices from before that, but that one really sounded like a human being with, like you said, with human inflection, and it felt like there's some depth. Is that the kind of thing that we're looking at when you talk about reinventing graphics and reinventing voice technology and using these newer technology, including AI and deep learning, to not only change the look of graphics, but change the feel and sound of a machine to make it sound more like one of us?
Yeah, that's right. Now, I should make sure that you understand that although that voice was synthesized, it was also closely directed. So that was not, I wouldn't say that was a push button speech synthesis system like you might use when you talk with a virtual assistant. Instead, it was a controllable voice that our algorithms allow the producers of the video to create. And one of the ways that they do that is by modeling the inflection and the rhythm and the energy that they want a particular part of the video of the narration to have. And so, I would say it's not just a story about AI getting better, but it's also a story about how humans work more closely with AI to build things, and having the ability to make synthetic voices that are controllable in this way, I think opens up new opportunities for speech synthesis in entertainment and the arts, I think. And so I think that's exciting, but it's something that that you and your audience should understand is that that was actually very closely directed by a person. Now, of course, we're hard at work on algorithms that are able to predict all of that humanity, the rhythm, the inflection, the pitch. And I think that we are going to, see some pretty amazing advances in that over the next few years, where we can have a fully push button speech synthesis system that has the right inflection to go along with the meaning of the text. Because when you speak, a lot of the meaning is conveyed through the inflection of your voice, not just the meaning of the words that you choose. And if we have models that are able to understand the meaning of text, like some of these amazing language models that I was referring to earlier, we should be able to use those to direct speech synthesis in a way that has meaning. And that's something that I'm very excited about. It's interesting. I feel that we have kind of a cultural bias. Maybe it's a specific to the United States, I'm not sure, but we have this cultural bias that computers can't speak in a human-like way. And maybe it comes somewhat from Star Trek: The Next Generation, where Data was like an incredible computing machine and he could solve any problem and invent new theories of physics, but he could never speak in quite the same way that a human could. Or maybe it traces back to,
Spock,
2001.
maybe?
Yeah, right. All the movies, right? The Space Odyssey, where we had the evil killer robot that was running the spaceship, Hal, and Hal spoke, but it was like off-putting. Like his voice like was creepy.
He was eerie.
He was really eerie. And so we have 50 years, we have like several generations of culture telling us that a computer can't speak in a human-like way. And I actually just think that's not the case. I think we can make computers speak in a more human-like way, and we will. And I also think that the benefits of that technology are going to be pretty great for all of us. So it's something that I think is a really exciting thing to work on.
The other thing that stood out in that clip was the Amelia Earhart picture seeming to come to life. Could you talk about? I'm guessing that's part of reinventing graphics using AI.
Yeah, that's right. So NVIDIA research has been, I think, really involved in a lot of technologies to basically synthesize videos and synthesize images using artificial intelligence. And that's one example. You saw one where, the neural network was colorizing an image, sort of giving us new ways of looking at the past. And when you think about that, what's involved in colorizing an image? Well, the AI needs to understand the contents of the image in order to assign plausible colors to them. Like, for example, grass is usually green, but if you don't know where the grass is, then you shouldn't color anything green. And traditional approaches to colorizing images were, I would say, a little bit risk averse. Like, they would kind of tend to make things that looked slightly colored, but it was mostly kind of gray, and it was kind of like tentative. But as the AI gets better at understanding the contents of an image and what objects are there and how the objects relate to each other, then it can do a lot better of assigning plausible colors to the image that kind of brings it to life. And so that's one example, this image colorization problem. But I think in that video we saw several other examples where we were able to take images and then animate them in various ways. And one of the technologies we've been really interested in is called conditional video synthesis, where you are able to create a video based on sort of a sketch. And for something like this, what you would do is a pose recognition that analyzes the structure of objects, for example, a face, and here's the eyes and here's the nose, and then assigns kind of positions to the object and sizes. And then that becomes kind of a cartoon, like a child might draw with a stick figure. And then what you do is you send that into another routine that animates that stick figure and sort of makes the person move their head or smile or talk. As let's say that we're doing it along with text, that we want to animate a person speaking to a certain text. Well, we can make a model that predicts how their stick figure model is going to evolve as as the person is speaking. And then once we have that kind of animated stick figure drawing that shows how the person should move, then we put it through a neural network that synthesizes a video from that, and goes sort of from the initial image that has like the appearance of the person and the background and so forth, and then animates it via this sort of stick figure animation to make the video. And we call that conditional video generation because there are many different videos that you could produce from the same stick figure. And so what we want to do is kind of choose one that seems plausible, conditioned on sort of some sort of other information, like maybe the text that the person is speaking, or maybe some sort of animation that we want to create. And so conditional video generation is a very powerful idea, and it's something that I think over time will evolve into a new way of generating graphics, a new way of rendering and creating graphics. And actually, I'm really proud of this, that in 2018, so this was already 3 years ago, at the NeurIPS conference, we actually had an interactive demo where you could drive a car around an environment that was being synthesized in real time through one of these neural rendering technologies. And I think that was the first time ever that humans had got to interact in real time with neural rendering. And I was pretty proud of that accomplishment. The technology over the past 3 years has gotten a lot better. I think, over the next 10 years or so, we may actually start to see neural rendering methods displace traditional graphics methods just because they're so much better. They're so much easier to create, and the results are so much more real.
There is even a piece of that video where the person basically said, draw this, and it actually started getting drawn.
That's right.
Can you explain that a little bit? Because that was one of those other things. Like I love when we're able to use natural language to do things, as opposed to doing, learning how to do things to do things. We know how to speak. Now the illustration of being able to paint by voice almost seems pretty incredible to me.
Right. Well, so, the power of deep learning is that it's a very flexible way of mapping from one space to another. And so in that video, we're seeing a lot of examples of that. And this is another example, but from the point of view of the AI technology, they're all kind of similar, because what we're doing is trying to learn a mapping that goes from X to Y. And in this case, we're trying to learn a mapping that goes from a text description of a scene to kind of the stick figure cartoon of that scene. That, so let's say I said, a lake surrounded by trees in the mountains. What I want the model to do is to understand that mountains, go in the background and they have the certain shape, and then the trees kind of go in the foreground, and then right in the middle, usually there's going to be a big lake. It's possible to train a model based on a lot of, if you take let's say 1,000 or 1,000,000 images of natural landscapes, and you have annotations that show like what are the contents of these images, then you can train the model to go the other way and say, given the text, can you create a sort of stick figure cartoon of what the scene should look like? Where does the mountains go? Where does the trees go? Where does the water go? And then once you have that stick figure, then you can send it into a model that elaborates that into an image. So that's kind of what you saw in that video.
There's a number of videos in that I Am AI set, which I just thought they were all fascinating. But I did find another clip, because to me, this has I think has significant impact for anybody that is doing something like we're doing now, a video call, or on a video conference, or a meeting with a whole bunch of people on a Zoom call, or whatever have you. And sometimes maybe we don't necessarily want to, well, I don't have the issue of wanting to put makeup on it. I don't. But there are certain people who don't necessarily want to get gussied up just to be on a call. I want to play this clip for folks to see, and maybe have you talk us through it a little bit after I play it. So here's the clip.
Hi, this is Kevin.
Yeah, ready for the interview?
Yeah.
So it says you're presenting a new AI-driven digital avatar technology to me today. Tell me all about it.
All right. Before we begin, can you tell me how I look on your screen?
Looks like you're wearing a blue-collar shirt and have recently shaved.
Would you believe me if I told you I'm actually wearing a t-shirt, hat and mask and chilling in a coffee shop?
Wait, no, that's definitely not what I'm seeing on my screen.
Yes, what you're seeing is the new AI-driven digital avatar technology I want to demonstrate to you today. The digital avatar you're speaking to is created by using just a single photo of me.
All right. Whoops. Let me get rid of that guy. All right. So what was cool about that is at the end, he said that image of him was generated from one photo of him. And it was his voice. You could, on the screen, you could see the movement of the mouth. The audio quality is great. And he's sitting in a coffee shop, which there could be lots of sound going on in a coffee shop, but we didn't hear any of that sound. We just saw him talking via his digital avatar with great audio and video quality. Talk us through that, because I think there's going to be a lot of people that are interested in that right now who would love to be able to be in a Starbucks with the hat pulled to the back, but still looking pristine as they talk to somebody via a Zoom call. Talk a little bit about that.
Yeah, well, we were really proud of that demo. I should also note that that demo won Best in Show at the SIGGRAPH conference this year, which is the biggest graphics conference in the world. So we had this there's this real-time demo competition there, and that demo won Best in Show, and we were very proud of it. It was a labor of love, I think, from everybody at NVIDIA who was working on it. That model was a generalized video synthesis model. We were talking earlier about how you can take kind of a stick figure representation of a person and then animate it. One of the limitations of models in the past is that you had to train an entirely new model for every situation. So let's say if I'm at home, I have one model. If I'm in the coffee shop with a different background, I need another model. Or if you are wanting to do this yourself, you would need one model for yourself in this place, another model for yourself in another place. Every time you create one of these models, you have to capture a data set in that location with maybe that set of clothes or those glasses on or whatever, and then spend a week on a supercomputer training a model. And that's really expensive, right? So most of us could never do that. So that would really limit the way that this technology could be used. And so I think the technical innovation behind that particular animation was that they came up with a generalized model that could work with basically anyone. You just have to provide one picture of yourself, which that's cheap enough. Anybody can do that, right? And if you go to a new location or you're wearing different clothes or glasses or whatever that day, you can just take a picture, and then the model, because it's general, is able to resynthesize your appearance with just using that one photo as a reference. And so I think that was pretty exciting. Now, later on in that video, actually, they switched to a speech synthesis model as well. What we heard in that clip was actually the main character speaking with his own voice, but later on, things in the coffee shop get so noisy that he ends up switching over to text, and so he's just typing, and the audio is being produced by one of our speech synthesis models, and so that's pretty exciting. I think giving people the opportunity to communicate in new ways, I think only helps bring people closer together. So that's a project that we were pretty excited about.
I could go on because there's a lot of interesting videos in that series, and I was like, oh, should I use this clip? Or can I only have a certain amount of time. I couldn't put them all in. We'll talk about the big picture ramifications for all these things that you're working on. Maybe you could kind of talk about it in terms of the conversational aspects, the conversational AI, and where you see that going, and how is that going to impact humans the most as you see it. And then maybe we could talk about the graphical pieces, and then maybe just the big picture, where we're going with all this. So why don't we start with the conversational AI, and how is that going to change, how we communicate and collaborate in the years to come?
Well, the primary way that humans communicate is through conversation, just like you and I are having right now. But it's very difficult for humans to have a meaningful conversation with a computer for a number of reasons. One is that it doesn't feel natural, right? Like if it sounds like you're speaking to a robot, that's a barrier that inhibits communication. It doesn't look like a person. It doesn't react like a person. And obviously, computers these days, most of the systems that you and I have interacted with don't understand what humans can understand. And so, conversational AI, in some ways, is the ultimate AI challenge. In fact, you may be familiar with the Turing test. Alan Turing, who is considered by many to be the father of artificial intelligence, set conversational AI as kind of the end goal of artificial intelligence. Because if you have a machine that's able to intelligently converse with a human, then you've basically solved any kind of intelligence question that you can imagine, because any information that humans have, any wisdom, any idea that humans have created over the past many thousand years, they've all been expressed through language. And so that means that language is a general enough way of, and it's, obviously it's the only way for humans really to communicate and complicated ideas. And so if we're able to make computers that are able to understand and communicate intelligently and with low friction, so it actually feels like you're interacting with a person, then there's a lot of problems that I think we'll be able to solve. I think some of the first problems involve things like making retail better, making customer service better, making interfaces better, like for example in your car or in your house, and also helping people. I think entertainment has a lot of value as well. People play a lot of video games. With the pandemic, I think people play more video games than ever. And, sometimes people play video games with other people. Sometimes they prefer not to. If they're able to interact with a computer in a meaningful way that's interesting and helpful, then I think that will open up new forms of entertainment as well. And, hopefully, I think make the world more fun and hopefully more useful. So I think conversational AI is going to continue to be a focus of research from the entire industry for a long time. I think it is as deep a subject as all of human understanding and knowledge. If you and I were having a podcast on, let's say, Russian literature, there would be a lot of specialist ideas that someone with a PhD in Russian literature would be able to talk about better than I would, for example, right? So even amongst humans, our capabilities in various subjects are going to differ, and that's why I think conversational AI is going to be a challenge that continues to engage us, for the foreseeable future, because it really is a challenge to understand everything that humans understand. And, we aren't close to doing that yet. But we have made a lot of progress recently. One thing that happened last year that, really, I think was a milestone for the industry was GPT-3, which is a model from OpenAI. And this model is trained on language. So basically what they did was download, as much of the internet as they could. And then they fed it to a very, very large neural network, one of the largest that humanity's ever created. And the job of this network is very simple. It is to predict the next word given some context. So given the past from the document, what's the next word? And so they made this model, and they were able to show that it was good in the sense that it fulfilled sort of the objective that it had been trained for. But what they found that was, I think, really inspiring for everyone is that this model because language is so general and the task of understanding language is so vast and sort of all encompassing, that this model, even though it had been trained only to predict a word, actually was able to do some simple reasoning and solve new kinds of problems. So one example that I just am continued to marvel about is that this model can actually translate from English to Spanish. This is kind of amazing because what it means is that the model had to learn a lot of high-level concepts about the world. It had to learn that languages exist, that humans communicate with languages, that these languages have parallel vocabularies. So there's correspondence between similar concepts that are expressed with different words in these different languages. It had to learn that the language that that one language that it had seen was English, and it had this vocabulary, and another language that it had seen from many documents on the internet was Spanish. It had to learn the connection between those words. And then it had to learn about the task of translation, where the job is to move from one language to another, including the grammar and the sort of the connections between the words, word order. And then it also had to learn that I was asking it to do a translation. Because the way you interact with these models is, instead of retraining them to do a new task, you just give it some examples. And you say, here's an English colon, and then there's a sentence in English. Spanish colon, here's a sentence in Spanish. Give it a few examples like that. And then you say English colon, give it a sentence in English, and Spanish colon, and leave it blank. And then let the model predict. And this format is actually enough for the model to understand and put all those pieces together and actually produce a proper translation on a task that it has never been shown before, right? So the amount of reasoning and the amount of association that the model needed to do in order to perform that task properly is far beyond anything that we've ever seen with artificial intelligence models before. And it speaks to the generality of this language task, that, because language describes everything that humans do, if we can make models that understand language, we're also understanding the world. We're understanding the structure of the world. We're understanding how things in the world interact. And then, that can be useful to solve a lot of problems. And then, sort of this idea that these models don't necessarily have to be retrained in order to solve new problems. You can just explain a new problem using language to the model and then have the model produce the proper result. Speaks to a form of more generalized artificial intelligence than we've ever had. And I think that's just really inspiring. Now, these models are not in production very much yet. They're very expensive. And also, we're still learning about their capabilities and, what circumstances, what contexts they're actually a good idea to deploy them in. One of the problems with models like these is that they reflect biases from the world that they were exposed to. And as you know, the world in which we live is, it's got problems of many different kinds, and, humans treat each other very badly. And so you train a model on the internet that contains examples of all of this. And then, it turns out that that model is probably not safe to be deployed sort of without restraints, because
I think Microsoft found that out years ago, right?
Years
when they
ago.
did that experiment.
Yes, that's right.
And I appreciate what you're saying about the kind of maybe the inherent biases that folks maybe not even know that they have. It's just, it's just their collected experiences. And if the set of folks who are kind of creating this technology are kind of homogenous in their makeup, you may miss things that seem obvious. Like, Facebook had to apologize recently about their AI and their facial recognition not being able to tell the difference between a black guy and an ape. It seems pretty easy to be able to do that. But if you don't have the right mix of people involved in creating these technologies, something as obvious as that could be missed.
Yeah, that's absolutely correct. And so I think the industry is aware of the sort of risks on these kinds of models. And so that's one of the reasons why we haven't seen these models extremely widely deployed yet, because we're still learning about how to train them and how to use them in a way that's safe and reflects the values that we prefer as a society. So I think we have more research to do. On the other hand, the power of these models is so undeniable that I think we are going to see a revolution in conversational AI. We're going to see human-computer interfaces that are a lot more fluid, a lot more realistic, a lot more thoughtful, and much more useful. I'm very excited about that. As just a normal consumer, having to interact with various companies here and there, including today. I got a new Tesla a few days ago. It's already broken.
Nice.
I needed to call Tesla support. That took several hours. This kind of thing, is going to be so much better when we are actually able to solve a lot of these problems with conversational AI.
I've been saying for years, being a watcher of the CRM industry and all the different applications people have to use, it will be a great day when people don't have to swipe and type and click and do all that. If they could just look, talk to their application. I want this, and have the application understand enough to give that or have a follow-up. That's going to be great. I can't wait for that day to happen myself.
We'll get there.
All right. Bryan, this has been a real pleasure speaking with you. Where can people go to learn more about some of the things that you and your research team are working on?
NVIDIA has a website, research.nvidia.com, that has some things on it. You can follow me on Twitter. My Twitter handle is CTNZR. It's my last name, just with all the vowels subtracted out of it. And we also have a website just for my team, which is nv-adlr.github.io, where we highlight some of our papers that and accompanying research results. I think also we have GTC coming up soon. We have GTC a couple times a year where we talk about the latest and greatest NVIDIA technologies, and hopefully we'll have some really cool things to show off soon at the next GTC in November.
Just for folks who don't know what GTC stands for.
It stands for GPU Technology Conference, and it's been going for more than 10 years, and it's kind of focused on developers, I would say, of people that use GPUs to solve problems. These days, that encompasses all of artificial intelligence, as well as all of traditional graphics and high performance computing. So it's a pretty diverse conference. It's usually keynoted by Jensen Huang, our fearless leader at NVIDIA. He always brings a lot of panache and a lot of exciting announcements, and it's sort of a platform for NVIDIA to talk about our latest and greatest technology.
I've seen one of his keynotes just on the replay. Those it seems like a lot of work goes into his keynotes too, from a technology standpoint. And I even watched the making of the keynote video, which gives you like a behind the scene. It's fascinating. I am definitely looking forward to seeing what's in store for this one, just because I was able to catch some of the things that his keynote was made up with in the past, because those inside the keynote, the making of, I've never seen any company actually put those together so that you can see what it all took to pull this off. It was really a fascinating thing.
Yeah, it is fascinating, and it's exciting for all of us at NVIDIA. I've been involved in helping GTC come together, a lot over the years, and it is an enormous amount of work, but it's a labor of love, I guess. But I guess the funny thing is that I usually am surprised myself. There's usually something cool that I didn't know about, and so it's always a bit of fun for me as well, even though I'm involved in some small way in helping with part of it.
This conversation has been so good. I have completely ignored the comments that were coming in the question. I am so sorry, John, Reed, Anand, Tucker. I'm just gonna just to show Bryan that people are really digging what you were saying and have questions. I mean, Anand is a buddy of mine. He's deeply involved in a lot of these things. He was going to work. Then my buddy John Reed came in and he started, sharing his experience. Yeah, Alexa device. get ready for the Alexa robot there, John. I know you're going to be signing up for that when that comes out. But yeah, thanks, guys. I really wish I had been able to incorporate these in a little better. I just got enthralled with the conversation. I really enjoyed talking to you, Bryan. And maybe we could do this down the line when other things that you're working on are sort of surface and are able to be discussed. I'd love to do that again if you're up for it.
Oh, that'd be fun.
Cool. Thank you so much, Bryan. And thank everybody out there for checking this out. I will be back tomorrow because, it's Thursday. It's CRM Players Day. And we're going to have some good conversation on that. But in the meantime, thank you so much. And I will see you guys tomorrow. Take care.
Bye.